Okay, so this is lesson 25, completing the square. So normally we give everything in standard form for an equation, and sometimes it's useful to take that quadratic and put it in vertex form. Because if it's in vertex form, you know the vertex right away. You could look at that and look at the x value and look at the y value. So it's really useful. Now to do that, we do something called completing the square. And what we're trying to do is we're trying to take any trinomial and make it a perfect square. So what we do is we look at a function. So here's one, y equals x squared plus 12x plus 32. So x squared has to be by itself. It can't be, the only coefficient in front of the x squared has to be 1. So what we got to do is we're going to find the vertex, write the equation of the axis and symmetry and all this stuff. But the main thing is that we have to complete the square. So it's just a bunch of steps. So here we go. The first thing you do, write out the equation. The 32 that's there, you move it outside over to the brackets here, right? So you move it over there, and then you can get a good idea of what you're doing for this thing here. So we move the 32 and we move the 32. Okay, then we look at this number here, the 12. This is the one we're going to be working with. And if it was negative 12, you use negative 12, but this is positive 12. So whatever's in front of the x. So I just do the work over here on the right-hand side. So I take 12 divided by 2, and then I take the result of that and I square it. So 36 is my number. So 36 is what I'm going to work with. Now, so what you do is you add 36 on the inside of these brackets because we're trying to create a perfect square. Now, to keep this in balance, you'd learn this a long time ago. In an equation, if you add 36 on one side, on the other side of the equal sign, you normally add 36. Well, we're doing this all on the same side. So if you were to add 36 way over here, to get rid of it, you would subtract 36. Or the other way to think about it is, hey, if you add 36 on this side of the equation, you have to minus 36 on this side of the equation to keep it in balance because that's 0. Okay, so now what we got here is, hey, we have this trinomial. We're going to factor it into two binomials. And if you did it right, it should be, if you notice, they're exactly the same. So where we get this number from is right here is the x plus 6. Okay, so x plus 6, x plus 6. Okay, now the 32 minus 36, there's our negative 4. So this one here, the x plus 6, can be double this up because it'd be squared and then minus 4. Now, that is vertex form. So if you look at this, you can tell what the vertex is. What number do you plug into this part here to make this equal to 0? Well, you plug in negative 6, and then the negative 4 is outside. That's your y coordinate. Oh, awesome. So let's graph this real quick. So a couple things. This is standard form. We know that the 32 here is the y-intercept. Now, of course, it's not going to show on this graph because we can't go up that high with the axis. We can factor it into two binomials, and then that tells us what our x-intercepts are, negative 4 and negative 8. It's a standard one, shifted 6 to the left and 4 down. The domain, same, negative infinity to positive infinity, or x is an element of R. The range, right, everything above or equal to negative 4. What would the axis of symmetry be? Well, heck, if you know the vertex, you know the axis of symmetry. It's x equals negative 6. Remember, it has to be in the form of an equation. This part here would be a minimum. Remember, it's at the bottom here, so the minimum. So that would be y equals 4 if you wanted to talk about the minimum. Okay, flip the page. Let's go to example number 2. We're going to complete the square. Now, this one's a little different. There's something in front of that x squared. And if it was a negative, you'd have to take that out. So in this case, we're going to take out a 2. And if you take out a 2, you got to take it out of just these parts. So first thing we do, before we take out the GCF, we push the 12 to the outside because that's way out there. So now we have 2x squared plus 8x. And what we got to do is we got to take a 2 out of here. We're just taking it out of the bracket part. We take a 2, so we end up with an x squared plus 4x. Okay, now what we got to do is we got to take the number in front of the x, divide it by 2, and square it. Now in this case, it's a 4. The common mistake is people always use, or students always use, the 8. You know, you got to remember you pulled the 2 out, so you got to use the 4. So over here, it's 4 divided by 2 equals 2, and then we square it, and then we end up with 4. So what we're going to normally do is we're going to add 4 on the inside. Now to keep it in balance, if we add 4 on the inside, we have to subtract 4 on the outside. Well, that's not a negative 4. What's that? That's a negative 8. Well, you got to realize, as soon as it comes out of this bracket, it gets dealt with the 2 there. Oh, we got to times that, negative 4 times 2. So we put the little numbers up here, and we realize it's subtract 8. Okay, so now we have a 2 here. We have our two binomials. Hey, it's x plus 2 and x plus 2. Where did we get that from? Oh, look, it's way over here, the x plus 2. So that 2 there is what we deal with, the x plus 2 and x plus 2. And then we're going to shorten it down to x plus 2 squared. 12 minus 8, so there's our positive 4. So here is our vertex form. Heck, we know the vertex now. It's negative 2, comma 4. Okay. What we can do here, the next part, it says verify that the two functions are equivalent. So this is something you got to be able to do. You have to be able to take vertex form and turn it back into standard form. Okay. So x plus 2 squared, that means x plus 2 times x plus 2 as two binomials. And how do you deal with those? You FOIL them. So you can see this part here, we FOIL them. We collected the two middle terms. Then we have to distribute this 2 in the front here. So 2 times x squared, 2 times 4x, 2 times positive 4. And then we deal with that. And then we still have this 4 at the end. And then we can take the 8 and the 4. And we end up with y equals 2x squared plus 8x plus 12. And if you look up the top, that's exactly what we have. So a couple things to take from this one. When you're trying to complete the square, this x square has to be by itself and it has to be positive. So if, for instance, if there was a -4 there, you would pull out a -4. If there was a 7 there, you'd pull out a 7. X squared has to be by itself. Second thing is this piece in here right in front of the x, the coefficient there, that's the one you work with over on the side to find the numbers to complete the square with. So give that one a shot.